So Cockpit provides a single pane of glass to help organizations to manage logical organizations and environments of Gravitee. So in this example here, we can see organizations representing different regions. It can also be departments. And then within those organizations, you can set up different environments like development, tests, and so forth. Let's jump to our Acme account, which is going to be what we will be using as an example for this demonstration. So Acme is a fictional finance and banking company. It has one organization only in Cockpit with a prod and dev environment, and it has an access management and API management installation for both the control plane and the data planes. So in this example, we can see two gateways here in this orange color. That effectively means that they are not healthy. Now we're looking at healthy gateways here, and we can see different tags. So we have an on-premise sharding tag, and we have a AWS sharding tag. So that allows us to have a distributed installation of gateways in a single shared environment. So Cockpit also works as a way to access different environments and organizations and different consoles based on the roles and access you have. So in the organization settings, you have this ability to configure these sharding tags. In our case, we have a Amazon specific sharding tag and an on-premise specific sharding tag. We can see here for the sharding tags that we have restricted certain groups to them. We're going to come and see what groups mean in a while. But basically it means that we can specify certain users in Gravitee to allow API deployments to certain set of gateways. Now, policy execution is a very central capability in Gravitee. With organization and platform policies, you can enforce policies that are executed on any type of APIs within the organization. Now, what we're doing here is we're basically saying that we want a set of internal policies, a flow of internal policies that only execute on gateways that are running on the on-premise tag. So specifically what we want to achieve here is IP filtering for on-premise gateway APIs for a specific range of IP addresses within our internal network. So you can build up this hierarchical level and relationship of policies across organization level and API level with this kind of very conditional logic as well. And for the different environments, you can see different gateway information like the plugins and properties associated with them, of course, the sharding tag, and also monitoring information like CPU and memory and heap consumption. So here we're looking at both the AWS gateways and the on-premise gateways that are distributed. Now, we covered groups before in terms of assigning them to sharding tags. So here we have 5 groups. We have bank customers, public consumers, reviewers, team alpha, and team beta. So team alpha and beta are kind of our API provider groups. So in Gravitee, we have configured multiple authentication providers in this environment. So we have employees, which is using a third party, or rather I should say a Gravitee enterprise identity provider. We have Google, which is for our public users of the developer portal. And then we have an Okta based on OpenAPI Connect, which is for our bank customers. So if you start having a look at the internal employee identity provider, we have something called group mappings. So group mappings is effectively what makes us able to provide rules to associate different roles and permissions in Gravitee with third-party identity provider mappings. Now, if you look at our social Google provider, we're saying that all of them will be public consumers. And we're saying for the banking identity provider, we're saying that all of them will be bank customers. So that allows us further on to control, for example, the developer experience for those different groups. Now, one thing that is important is that Gravitee has a lot of different out-of-the-box roles across different scopes and permissions. So we have create, read, update, delete across things like reviewing, quality rules, and those are the roles that we have associated with an API reviewer role. So the API reviewer role is what is associated with this particular reviewers group right here. Now, the API reviewer is going to review every API provider's API as we've enabled this API review here. And we've also enabled the API quality metrics, which basically allows organizations to customize what the high quality API is measured like. Now, for this next demonstration, At Acme Bank, we're going to assume that we have an existing upstream SOAP service that takes an incoming number like 1 through 2, 3, 4 and responds with the words of that amount, like 1,234, for example. So we want to modernize this SOAP service. We want to expose this as a RESTful API and apply different types of traffic shaping, security, and monetization on top of this particular legacy API. There's a lot of options to create or import something to create an API in Gravitee. In this case, we're going to take this WSL file that describes the SOAP service. So we're going to take the URL and we're going to say that we want to create an OpenAPI specification. We want to create some policies so that Gravitee automatically proxies from REST to SOAP over this legacy service. So we're going to hit import, and Gravitee now automatically creates this API based on that SOAP service. Next, we will create plans, which is basically what defines the relationship between an API consumer and our API that we have created. So the first plan is going to be a full access plan. This is going to be a more secure plan that is going to be used for monetizing on consumption. So we're going to say that this is associated with monthly subscription. There's no restrictions on the number of API calls that you can make with this particular plan. And there's an SLA in place that Acme has to maintain towards a consumer on this plan. And that's why we're passing this general conditions as well to indicate the different rules and restrictions and enforcements across this particular API contract. We can decide here if we want to automatically validate subscriptions or if we need someone to physically approve, and we can also require someone to leave a comment. Now, in this case, we're not going to do that. Instead, we're going to have manual approvals. And we could here have selected that we wanted this plan to only be available across certain distributed type of gateways. And we could have said that we only want this API and this particular plan, to be discoverable and subscribable by certain groups in Gravitee. Now, for the authentication here, we've selected JWT. We also support things like OAuth2. And here I'm going to be typing in the access management gateway that is going to validate the token. Now, we're not going to enforce, as we mentioned, rate limiting and quota here, but we could have enforced things like resource filtering to determine certain services in our upstream SOAP service that is just not going to be available with this particular plan. Next, we're going to add a more restrictive plan. So we're going to call this a restricted trial. We're going to say that this is a free trial characteristic. You're going to be limited to 10 requests per second if you use this plan. We can also say that the subscriptions are automatically validated. It's not going to go through an approval process as it's a trial, but we are requiring people to leave a reason why they're subscribing to this particular API. And for the security here, we've selected an API key security. So we're going to set the rate limiting here as part of this particular plan. We're going to set that to 10 requests per second. Okay, so we have a complete lifecycle around plans, and the last thing we need to do is just publish the plans from staging to the publish, so that once we expose the API, consumers can discover and subscribe to those plans if they have the right access. So the next thing we want to do is to use the Policy Studio to do some mediation on our API. So we saw previously in the platform policies how we could apply generic policies to be applied for every API depending on which gateway and sharding tag it was executed to. Now in this case, we're going to be very specific to this particular API. So we can see here that we have the restricted trial plan, we have the full access plan, and then we have general flows based on the operations available to the upstream SOAP service. We didn't provide any specific restrictions for the full access plan, but for restricted trial, we provided a rate limiting, so that's now represented by this rate limiting policy. So how it works in Gravitee is you drag and drop policies on different flows, both on the request phase and on the response phase. So on the number to words operation, we have automatically applied a REST to SOAP policy to transfer the REST and HTTP with query parameters and stuff like that into a SOAP envelope that goes towards the upstream SOAP service. And after the backend response with an XML, we're going to automatically translate that to JSON using the XML to JSON policy. So these policies are automatically applied based on the WSL import that we did. Now for the REST to SOAP policy, we have the ability here, if you just copy and paste from the documentation, to use what is called the expression language with Gravitee, which is a very rich language to inject data into different transformations and to do various things like transformations and stuff like that. So what we're doing here is we're saying that in the SOAP envelope that goes to the upstream SOAP service, we're injecting a query parameter that we're gonna call number that is going to come to our gateway. Gravitee has more than 60 policies that span security, transformations, performance, and more. Some examples are the JSON threat detection policy for protecting against the malicious input, and the SSL enforcement policy that allows for MTLS use cases with dynamic and specific certificate patterns, and then the XSL transformation for XML payloads. While we use the XML to JSON policy for converting the upstream SOAP response to JSON, we want to make sure that the response is a bit easier to read. So we'll be using the JSON to JSON transformation, which allows for Jolt syntax to redefine the JSON messages. Policies execute in order, so XML to JSON will happen directly after the upstream response before our JSON transformation kicks in. Let's give our paying consumers a more performant experience. Gravitee supports a lot of resources to support API experiences, including different caching capabilities. So we will create a Redis cache resource that we'll use in a cache policy, invoked only for the full access plan. As the upstream will always return the same response if the input number is the same, we will be clever and use the expression language to point to the number query parameter as the cache key. If you're using the full access plan as indicated by the plan's characteristics and terms and conditions, you might get charged for your use of the API. In this video, we will come back to how API providers can build dashboards and reports to invoice users. But to enable this, we will use the assign metrics policy and create a metric called number length that will be assigned a number of characters in a number coming as the input. So if the user wants to convert number 10, it will be 2, and if they want to convert number 100, it will be 4. We will only charge for calls that are not hitting the cache. If we wanted, we could be even more granular and say, for example, to only charge for successful API calls. We will now, as API providers, ask for API to be reviewed before we can start and publish it. As configured using the API review mode and API reviewer role, another user will perform this action. This user, Alice, will sign in using our corporate identity provider. Gravitee comes with different types of tasks, including API review, API subscription, and API promotion requests. And Alice will review the draft. And while the API is not yet meeting the quality standards, we will accept the current draft. Before we publish the API, we want to try out the logic. So back at our API provider, we will now select which set of distributed gateways this API should be deployed to. As we belong to the beta team, we can deploy to both set of gateways, but this will be an external partner API and we will only run on our AWS gateways in this case. So to simulate an API consumer, we will create an internal application and subscribe to the restricted API key plan, which should give us an automatic approval as well. Once our application is created, we will save and note down the generated API key. And Gravitee provides a very strong testing and debugging tool as an alternative on top of things like OpenTelemetry with clients like Zipkin and Jaeger. So while we set this request up, let's put in number 941 as the number query parameter and try it out. All right, so first of all, we can see the end response to our client, which should look very neat. Now we can go through each and of the single of the policies here, for example, the REST to SOAP transformer policy, to see how we actually injected that query parameter into the SOAP envelope to the upstream. And then as the response comes from the upstream, we can see how we use that XML to JSON to transfer the upcoming XML to a JSON response. And then we needed to use that JSON to JSON Jolt transformation to make it look much neater. So the next thing we want to do is create a custom analytics dashboard for our metered number call. So Gravitee comes with a lot of out-of-the-box dashboards on different levels, but we're going to start creating a custom one specifically on the API level. So for this particular dashboard, we want to take advantage of the custom metrics that the assign metric policy added for us in terms of that number length that is going to be the foundation for our analytics reports for API monetization purposes. So the first one is going to be a line graph that's going to represent maybe a trend of how large those numbers are that people are asking for numbers too can be converted into text. So we're going to use that custom number length here. We're going to add another type of analytics chart here, which is going to be a table, also showing the number, custom number attribute projected by the hits. And finally, we're going to add a pie chart to illustrate what popularity different number lengths have. Are people asking mainly for 5,000 type of numbers, or is it the 20s, the 30s, etc.? This is going to then act as the foundation for when we invoice and bill our consumers. Now, as this is a API that has terms and conditions and is paid, we obviously need some type of mechanism as API providers to understand if we are in breach of an SLA towards a consumer. So we're going to create an alert here on this API. We're going to select that we want this to be alerting us when there's a particular condition that happens. In this case, we want to be alerted if the threshold of the response time exceeds 100 milliseconds. We can provide extremely granular and complex conditions and filters and projections. But now we're going to settle for that. We're not going to provide any dampening. We want to get a notification every time the NSLA is breached, but we could obviously, to prevent us getting spammed, configure more advanced dampening. So while we support things like webhooks, Slack, emails, we're going to be using a webhook notification here to just simulate how it looks when we are receiving an alert in case of a breach. We can use a pretty advanced system to customize and make the request bodies dynamic in the alerts. So here we're talking about their API name, the response time it actually took, the application name, and the owner of the API, the application, as well as the plan that was invoked. The next thing we're going to do is look a little bit on the upstream endpoint. So we've configured our upstream here thanks to the whistle we imported. Let's call that endpoint data center 1. Just to illustrate that we could, if we wanted to, add another endpoint, maybe call that data center 2, and have another alternative upstream URL that might live maybe in another server park or another data center for high availability. We can configure different types of load balancing mechanisms. So by default, we use round robin, and we can use this wait number if we wanted to as well to maybe do things like rollouts and granular kind of canary deployments and stuff like that. Now, for each endpoint, you can be very granular in terms of configuring MTLS and proxies and other capabilities. And one thing that you can enable is the service discovery mode with integrations like Eureka and Consul service discovery, which will automatically populate endpoints based on the availability and under upstream microservices that may exist in a particular cluster. We also want to have a health check to give a healthy API quality. So we can do very advanced health check configurations here. In my case, I'm going to be setting that I want every minute the gateway to check whether the upstream is healthy or not. And I'm going to use a simple assertion whether or not that upstream is returning at 200. But I can be very granular here. Now, finally, for API quality, we're only missing 3 things. We miss our own icon. We miss this API being associated with categories, and this API being associated with labels. So let's go and add an icon to represent our API in the developer portal, and then add a few labels here to allow easier search and navigation for consumers, as well as a category that is going to help both with how we expose this API in terms of discoverability, but also in terms of user access. For API documentation, we can see the terms and conditions document, as well as the OpenAPI specification that we generated by converting the imported WSDL file. Gravitee supports API creation through importing both OpenAPI and WSDL files, and soon also AsyncAPI. On top of what was generated, we could create additional pages for AsciiDoc, AsyncAPI, OpenAPI, and Markdown types, as well as creating a nested folder structure of different pages. So if you look at the OpenAPI auto-generated from the WSDL, we can inspect and edit the specification in a live mode. We can provide translations based on consumers' browser locale. We can enable things like try it mode and decide what type of OpenAPI rendering frameworks to use in the portal. It's quite common that API providers link existing version documentation pages, which Gravitee can pull from external sources like Git and HTTP sources. And it's also possible to control whether the page is accessible to all users, authenticated user, or potentially individual groups and roles. Now, Gravitee APIs can be versioned using different strategies, either by using the duplicate capability or more commonly by creating a product API that fronts multiple versions. This allows for things like A/B testing strategies and for when consumers need to determine which version to use by specifying a path or query parameter. Gravitee can also be configured with multiple logical environments through Cockpit, like dev, test, and production, and so forth. And users can use this promote feature to ask for promotion of assets to higher level environments. So let's start our API on the gateways. Just before we publish to the developer portal, let's make sure that this API can be accessible to users in the public consumer group. Now, this is the group that authenticates with with Google, as per our authentication provider and group mapping set up earlier. Let's review some of the admin configuration to build the developer portal experience. Similar to how we configure the API documentation, we can add AsciiDoc, AsyncAPI, OpenAPI, and Markdown files for general documentation. We can control the navigation and structural hierarchy of the portal by configuring various links across headers and other parts of the website. To control the look and feel of the portal, we can use the theme capability, either by using the what you see is what you get editor, or by managing the customization as JSON files. So this theme editor allows us to change a ton of images, colors, and fonts and other parts of the website. Some users prefer to build something from the ground up or directly into their existing websites, and every action in Gravitee is a REST API call, including everything that powers our own developer portal, like API lists, application, and subscription actions, and so forth. One example of a user who built their own portal powered by such APIs is the Postal Services of Switzerland, Swiss Post, where users can discover, subscribe, and use APIs across shipping options and partial label printing. By using these REST APIs, all Gravitee concepts, such as plans and applications, can be reused into other applications. Now, for Acme, we have 3 categories of APIs that have been created for easier navigation in the portal. So earlier, we added our number conversion API into the partner category. Optionally, we can highlight certain top APIs that should be featured in the portal. So let's go ahead and add our latest partner API to this list as well. Now, earlier in this video, we configured identity providers for employees, customers, and other sets of public users. Now, here we have enabled 2 of them, the Google and customer providers, for developer authentication. So if you remember with our group mapping in the beginning of this video, any user signing in with Google will get the partner Gravitee group assignment so that they can interact with our number conversion API that we did assign specifically to partner group. And later on, we will benefit from the dynamic client registration capability of Gravitee so that consumer applications can be synchronized, for example, with the Gravitee Access Management solution for building rich and secure consumer experiences on top of the APIs. First, let's explore the developer portal as an admin user. First of all, we see our top APIs, including our newly published number conversion API. The powerful search capability will search through API documentation and metadata to more accurately find APIs. Let's have a look at some of the navigation items we had added before across specific Markdown pages, direct link to the partner category, an external website, the list of all portal documentation, existing applications, and of course the API catalog. So the API catalog shows the 3 categories we had defined. It shows a section of all the APIs, featured APIs, which is the top APIs, and then starred APIs based on consumer ratings, as well as trending APIs based on activity and popularity for new APIs. Let's now sign in as a partner using the Google provider. So this will give us access to only partner APIs thanks to the identity provider group mapping and API group assignment we configured before. Our goal here is to see if there's some interesting APIs for us to consume. So we will have a look at the API documentation, potentially trying the API out, potentially create tickets with the API provider, and then we will get responses back in the ticket section from the API provider. And we will actually perform a 5-star rating of this API. Maybe a bit premature as we haven't tried the API out yet, but we'll still do that thanks to our excitement. Now, when we subscribe, we have two options. Either we use the plan that is rate limited and restricted and uses API keys, or we use this fully fledged contractual OAuth2 JOT protected plan that also gives us as a consumer an SLA. So to subscribe, we first need an application. So let's call this the partner sign-in application. We will be using this application as a consumer and as a developer, building a very rich and secure experience on top of this underlying API. So currently the admin has only configured one type of application, which is the simple application. So let's go ahead and go with that. And then we'll have to agree with the terms that have been set out that we did as an API provider previously, as well as providing an option justification for why we would like to subscribe. Now, unlike the previous internal debugging subscription we did with the restricted trial plan, this plan needs an actual manual approval before we can use it. So in Gravitee, admins can configure custom notification across email or webhook to integrate the approval workflow with other systems. So here we see an example of a webhook call that represents the subscription request we just initiated as a JSON response. Now, again, in our case, we'll be using the approval system that is built into Gravitee to accept this subscription. So now when John Doe, the consumer, is refreshing their application, they would be able to see that the subscription indeed has been accepted. Thanks to dynamic client registration, John Doe can configure advanced and modern authentication experiences over the API. So let's have a look at some of the admin settings available to a domain owner in the Access Management console. So firstly, all screens like registration, sign-in, consent, etc. can be easily themed using a visual or HTML editor. Identity providers across social, such as Facebook and GitHub, or enterprise like Kerber, SAML, or Active Directory, can be enabled for application owners to leverage in their authentication experiences. Multi-factor authentication providers can be enabled across many different factors, including one-time passwords and SMS confirmations. And we can enable things like bot detection, using reCAPTCHA, as well as enabling advanced OpenID certified profiles like financial grade API or FAPI. Now, as John Doe, we now have a lot of capabilities at our disposal. We can control which OAuth2 flows can be used to retrieve a token for our application. We can enable mobile-specific authentication enhancements like PKSCE or CBA flows. We can configure custom scopes and claims that can be added to the generated tokens and then later be used in the API flows to control the traffic based on those token details. In our case, we have enabled Passwordless, sometimes known as WebAuthn or Feeder2, as a means of authentication seamlessly for our end users. And we could enable MFA using the factors available to us, including the ability to ask users for factor confirmation based on perceived risk, for example, through non-reputable IP addresses or impossible travel. Now, using flows, we can drag and drop complex logic using policies for different activities in the sign-in or registration processes, potentially to enrich user profiles, maybe in the scopes that can then be used and acted upon inside the actual API policies. It's also important to point out that all of these capabilities around multi-factor authentication, advanced federation with identity providers, and so forth also powers the Gravitee Consul for administrators and can power the developer portal authentication as well. Let's go ahead and try the experience out end-to-end using the Postman client. For authentication to our number conversion API, we first need an OAuth token, which will be retrieved on the behalf of our partner's sign-in application. So in Postman, we enter the Gravitee Access Gateway URL or application ID and secret, and then request a token. We will use a default demo end user, and as this is the first time we sign in with that person, we will have to add our passwordless device for future seamless authentication. So now we have a token that can be used towards our API. Let's put in a number with 5 digits to get a high number length. The API response looks as expected. Now, as the API consumer and application owner, I can actually add other members to my application to manage subscriptions and other settings. I can view analytics dashboards provided by the API provider for how my application's APIs are performing. I can even, if enabled, drill into logs to troubleshoot issues associated with my API calls for my application. In notifications page, I can set up custom webhook notifications for events like accepted subscriptions or answers to support tickets that I've raised. And then under alerts, I can configure my own alerts based on events for my application's communication with subscribed APIs. Okay, so let's see what we can learn as an API provider after this interaction. So in the alert that we configured as an API provider for this API, we can look at the history to see that this API has been breached in this SLA a few times. We can look at the notification channel, which in our case was the webhook one, that gives us an idea of what the messages looked like when it came in. What we also can do is we can look at analytics. So as I mentioned, Gravitee comes with a lot of out-of-the-box dashboards across APIs, applications, and the platform. We can view our API's performance. We can look at kind of the geographical distribution of where the API calls are coming from. We can also look at individual user information to understand, for example, browser and devices and what actual end users are calling our APIs. And we can also look at the custom report that we built for monetization purposes to see, for example, for the partner sign-in application, what is the length of the numbers that are passed in so that we can then generate billing reports, whether that is from Elasticsearch, Datadog, or Splunk, or the REST APIs to retrieve this sort of data. Now, in terms of analytics, in terms of the whole platform, there's a bunch of different out-of-the-box ones to look at as well. The one I wanted to highlight here is distributed gateways, which is a customized dashboard that I created as setting up this platform. So this gives me the ability to view API performance based on particular gateways and understand latencies in a distributed architecture of analytics as well. And with Gravitee, you can automate the versioning and promotion of assets in different ways. So you can use the fully fledged REST API, you can use the promote capability, as we mentioned, and you can also export and import APIs. So whether you use the underlying REST APIs to version the JSON structures, or you work in a more cloud-native environment using a declarative approach, you can, for example, export your APIs as custom resource definitions. So we can see the generated YAML file right here, which is the API definition CRD. Now, one of the optional CRDs that we have is the management context one. This one controls the relationship between the Kubernetes operator and the Gravitee control plane, should there be one. But that is not necessarily always required. So an API definition that can be seen here, for example, which is the Echo API, named API, it can have the local flag set to different things. So if it's set to true, Gravitee will operate in a local mode and not push the API to the control plane. In this case, local is set to false. So when we apply this in Kubernetes, we will receive an API looking something like. So here we have the Echo API as indicated by this Kubernetes origin. It's a read-only type of API. Now, with Ingress, Gravitee can provide API definitions with the template set to true. So this allows Ingress resources, native Ingress resources in Kubernetes, to rely on the Gravitee Ingress Controller and optionally point to a particular template of the Gravitee Ingress. So in this case, we have an Ingress Kubernetes resource here with one host and one backend service. So when we apply this using Kubernetes apply, it will look something like this right here. So again, a read-only API where we can see that the entry point is using that host, and we can see that the upstream is this particular one right here. And if you look in the Policy Studio, we would have had more complex routing here should the Ingress have had more paths and services associated with it. So next, we will create an API design using a very visual and intuitive and collaborative approach. So as Acme Bank, I'm going to be creating a new service. So I'm going to call this the Pension API. So I will have two resources in my API. first I want to have a resource for the plans, and then I want to have another resource to represent the forecast for my pension. I'm gonna, for the forecast resource, only allow read and search operations, and then for the plan one, I'm gonna allow everything. I can configure different labels here, so I can say that this forecast is something that a customer has required, for example. I can configure attributes. I'm going to have a list of multiple forecasts in an array, and if each forecast should have a duration, which should be of type integer, and then I'm going to have another attribute, which is going to be the confidence score of this forecast, which is going to be a number. Now, if you look at the plan resource, I'm going to be adding a example of an ID, so free, for example. And for the other attribute of a plan, which could be, for example, the name of the plan, I'm also going to give this an example. So an example of a pension plan can be Nordic Invest A. And then finally, I'm going to be adding a third attribute here for my plan resource, which is going to be the customer name. Now for customer name, I'm going to say that that is a PII sensitive label. All those labels are fully customizable. And I'm going to give that an example of John Doe. So that's how easy I can create a data model that I can now generate an OpenAPI specification and have that running as a mock on the server. So I can in real time see what that looks like. I can see responses and mocks that are provided by the different resources. I can see the schemas of those underlying data structures and see how those kind of examples also play out. So I have a few options here of how I want to run this, but now I'm going to select the published API that allows this to be deployed to the developer portal as well as running as a mock API on the API gateway. So when I open up this API in the API console, I can now configure things if I need to. You'll see that it has automatically generated all these flows with mock responses based on the mocks that came from the designer view. So that is ready to go. If I need to, I might deploy that to particular gateways for particular partners or consumers to try this API out and then give feedback. So I'm going to deploy that now on that set of gateways. And if I just point in that URL and that particular path, I immediately got the response based on the mock. So far, we have discovered creating APIs by importing specifications such as WDSL. We have looked at Ingress and Kubernetes Operator API creation, as well as using the Visual API Designer. Now we will create an asynchronous API using the API creation wizard in the console. So as Acme, I want to provide a real-time multi-channel API where end customers can subscribe to stock updates. So the type of API we'll be creating will be able to mediate over event broker technologies and expose data publication and subscriptions using web technologies like REST and webhooks. Specifically, I can use HTTP GET to perform long and spontaneous polling. I can use HTTP POST to maybe inject data. Maybe in a Kafka topic, I can use server-sent events for web streaming and WebSocket for bidirectional streaming. For Webhook, API consumers can register in the developer portal and then provide their callback URL to receive messages from the upstream event broker technology. For this particular API, I will give consumers the ability to receive stock updates using WebSockets or webhooks. I will, however, configure the WebSocket entry point to only allow subscription and not publication of messages. So the upstream data source here, the actual stock updates, live in my internal Confluent Kafka cluster. On top of Kafka, Gravitee supports RabbitMQ, MQTT, Solace, and also a very friendly mock upstream service to immediately push out messages for debugging purposes. And I will enable the gateway to connect to it using SASL SSL. So with Gravitee, I can dynamically configure things like topics doing runtime logic, but in this instance, I will hard code a single shared topic for my consumers. So like previously, I can create revenue generating and restricted plans for my consumers, but in this case, I will allow anonymous access as well as the specific push plan used for Webhook consumers in the portal. So everything looks good. So let's go ahead and create this API. With the next generation of our Policy Studio, users can configure flows and apply policies on both requests and responses, as well as publish and subscribe phases, where policies can actually execute on individual messages and packets. And this is quite unique and opens up for many interesting use cases. So for the stock API, what I will do is I will create a specific flow just for webhook consumers. So I can add policies to filter messages, normalize with cloud event standards, or integrate with schema registries for serialization and validation. But in this case, I will ensure every streamed message gets converted from JSON in the broker to XML as it receives the webhook callback URLs. Over WebSockets, I'm not going to make any changes, so the WebSocket consumers will still receive JSON messages. Now, as API consumers, we can view AsyncAPI documentation, we can subscribe to plans. Now, in this case, I will subscribe to a push plan where I will have to configure the callback URL of the server where I want to receive the messages that the gateway picks up from the Confluent Kafka topic. Now, on the top left here, we have the Confluent Cloud Console, where we are ready to push messages about stock updates into the topic. In the top right-hand corner, we have a WebSocket consumer client that has established a connection to the gateway for receiving these JSON messages coming from the Kafka topic. And on the bottom, we have a webhook server that listens to the callback URL registered in the developer portal about application. Now, as we push these messages through, we can see how the WebSocket client received those JSON messages, while the webhook server callback receives the transformed XML messages.